Good afternoon. Welcome, everybody. It is wonderful to be here, and I am excited to welcome and introduce our speaker today, Dr. Anthony or Tony Essien, from the University of the Witwatersrand in Johannesburg, South Africa. Some of the background is that Tony and I met about, I don't know, 8 or 10 years ago. Through the ICME community, and we made some connections internationally around our common interest in language and mathematics and multilingualism and mathematics. We've worked together with a number of common collaborators, and editors, and mentors. And so it's a real pleasure to have this opportunity to welcome Tony to San Diego, to introduce him to our context and to share and to learn together. And I was trying to think of an interesting fact there. We commiserated around trying to help our children in mathematics and how delicate the balance is when you are a math education professor and you have children, and the levels of connection when you say, let me help you with the math homework. And they say, just tell me the answer. So with that, Tony, we're excited to welcome you. I will say that I'm going to go upstairs and watch from my office in the interest of everyone's comfort. I brought back the bug from AERA. I'm now cleared, but just in abundance of caution, I'll make sure everyone feels comfortable. So I will be here on the Zoom, and please join me in welcoming Dr. Tony Essien.
Thank you very much. Yes, and I appreciate your coming. How many do you have online? I also appreciate them being able to join us online.
Counting the 3 here, it would look about like 5.
Okay. Oh, I see 9. I see 9.
You see that?
Oh, okay.
No, it just popped up to know.
All right. Okay, thank you. Okay, so I would like to start with this so that I paint the picture for us. We have a different context here, or you have a different context here. Your context is more that of immersion. Either you are here, I know you must have learned French and English before you came here, but you are immersed into English. It's very different from when you're in Burkina Faso and you are in fact sitting alongside with multiple languages. All right. I just use that example as an opportunistic example because he just met now and he told me this for Burkina Faso. Okay, so when people think of the African context, so what they see is high linguistic diversity. But then there's something that hides behind, that lurks behind that visible aspect of language diversity in Africa. And it is peculiar to many African countries. It is in fact the distinctive nature of multilingualism within different contexts in Africa. And I'll cite an example. In South Africa, for example, we have 11 official languages, of which 9 are indigenous languages. And then within the 9, we have 2 that are autonomous. So completely autonomous, they don't share much lexicon. So we're left with 7. Within the 7, there are 2 subgroups. One of them are, and each language in the subgroup are mutually intelligible. So if I speak language A and you're in my group, it might not be your language, but you can understand me and we can communicate. That is very different from a context like Nigeria. And perhaps you can share your own perspective at some point, where if I am in a cosmopolitan city and I decide to use any language, one language, the chances are that I'll probably reach only one person. While in South Africa, if I speak one of the languages, because of the mutual intelligibility of the languages, more people are more likely to understand me, and therefore, something like code switching as a practice takes on a different kind of perspective in these 2 contexts. Okay. So also what people see is the colonial history regarding language. So there's the colonial language versus versus the indigenous language. But again, what is hidden are the cross-linguistic issues between the so-called world language that's being used and the local language. I'll cite an example soon. And then again, when we read about work on multilingualism, we tend to see, oh, translation, we don't have this vocabulary, we don't have that. And so that's what we see. But there are issues around dialects too. Again, I'll cite an example. And then we also see and talk about limited proficiency in English or in French. But what we don't see are also varying proficiencies, even within the different home languages that we sit in class with. Okay, so let's look at one cross-linguistic issue. I particularly like this task. And I just told some of you that I teach the postgraduate students a course on language and communication in mathematics education. So I give them this simple task. If the number of dots represent the amount of rainfall, which month has the least rainfall? It used to at first baffle me, but after a while I started understanding why. Okay, South Africa is made up of a context where we have first language monolingual, we have monolingual English speakers, we have bilingual people who speak English and Afrikaans, that's close to Dutch. And then we have a lot of the Africans who speak diverse home languages, but also many languages too within the 7 languages I talked about. And it used to baffle me how a lot of the monolingual learners or students in my class who say it is fair. And then, but the multilingual ones who say no, it must be matched. So it got heated one year that one person said, he got up in the class and said, this mathematics is going to make us fight. How can you tell me the answer is fair? And then pointed to the person who was insisting it was fair and said, if I have 3, let me use dollars. If I have $3, you have $2, you have $1, and you have no money at all, who has the least amount of money? Shouldn't that be you? And you know, the person said, no, but it's actually Abel who's got the least amount of money. So how can it be? How can it be? And you know, Zellenbecken talks about linguistic capital. So it's about the linguistic baggage you bring with you when you come into class. And so the assumption is that, you know, in any of our indigenous languages, to comprehend the word least, you cannot understand that word least in the absence of nothing. It is completely nonsensical to say this is least when there is nothing there. There has to be something for which the least amount is judged as the smallest amount. So when there's nothingness, it doesn't make sense. Think of your language, Eva, and see. If I say least, what does it mean for you? Who's got which month has the least amount of rainfall? I'll come back to you, Eva, at some point. What I'm trying to do is to say, okay, let's look at this. I take five pens. Imagine these are pens, and I put them on the table. I said, okay, translate this in your home language for me. There are 5 pens on the table. So then progressively, I take out some pens. Then I said, there's 1 pen on the table. The person translates it, no problem. And I take out the last. There is 0 pen on the table. And then there's silence. And then they translate. And I said, no, you have just translated that there is no pen on the table. Now there is 0 pen on the table. Either in your home language, can you translate there's 0 pen on the table? It turns out to be there's no pen on the table, right?
Yeah, you have to refer to the item you're talking about.
Exactly. And so that makes it difficult for learners, for students to begin to think about the concept of 0 in a context where there is nothing, and therefore they choose March as the month with the least rainfall. Now, if you don't understand this cross-linguistic issue, and if you simply think the issue is proficiency in English, this has nothing to do with proficiency in English. They could be very proficient in English, very proficient in their home language, but because of this issue, because of that linguistic issue, they are unable to tell you the answer is fair, because the concept of zero is not simply there in their home languages. Okay. This is another task, and I just, okay, what Bill did not tell you is that I assumed the role of numeracy chair. I think it's 1 year and a couple of months now at my university, and there are 2 numeracy chairs in the country, funded by the government. And so we were trying to look at this task where we are teaching the grade 2s mental mathematics. So 2 more than, that's just a concept. And we looked at this, 2 more than 27. Hey, 2 more than 27. We looked at the translation in the different home languages that we're using. And you see, when you say 2 more than, it could be 2 in addition to, and it ends up being translated as 2 on top of 27. Now I've got 27 there, 2 on top of 27. Now, when you translate it as 2 on top of 27, the meaning changes in mathematics. Okay, on top, 2 on top, where would that be? Is it this number? Is it, maybe it's clearly not 29. Clearly not 2 on top of. Doesn't make sense in English, but it does, that's the translation in the home language. And so there are all these issues that we have to contend with. And another issue is that of some languages where some terms in one dialect would have a completely different meaning in another dialect. And another thing I did not mention is that a particular word in a particular language can have different meanings. Okay, I normally start the example with the word, with one word I know in one of the languages that can translate into 5 things. One word can mean the bush, the forest. It can also mean money, but it can also mean husband. depending on the intonation, so the tonal difference. Okay, so just the term is just OKO. When you pronounce it as oko, that is money. If you pronounce it as oko, okay, then oko, that is a boat. If you pronounce it as oko, that is forest. And then if you pronounce it as oko, that is money. Okay, so things like that. So they do exist in a lot of the African languages. So what then is the problem? I mean, we are teaching in such a context. Okay, South Africa is highly multilingual, just like many other African countries. And research has shown that teaching and learning in a context like that is complex. Richard Bauer, who was my supervisor, talks about the triple challenge. Paying attention to the mathematics when you're teaching, and then you have to pay attention to the language, but also you have to pay attention to the mathematical language. And I've added here the 4th one, you have to pay attention to the interaction between the languages that are present in the class. And for us in teacher education, one of the greatest challenges is how to prepare pre-service teachers to deal with this complexity of teaching effectively in multilingual classroom. And that has been the focus of my PhD and my current research. And research generally, research has focused on practices specifically more in the primary schools than in the secondary schools. But there's been also a great depth of research in teacher education. It's only now that we're beginning to see a lot more research in teacher education than before. And for me, so my PhD was focused on preparing pre-service teachers to teach in multilingual contexts. But one of the things I noted was the whole idea of practice, what makes for a good practice. I could see that teachers were able to do A, B, and C, or the lecturers, but then they could use examples, for example, they could use code switching, they could use revoicing as a practice, but what makes for a good code switching as a practice was not evident. What makes for a good, what principles are used in the choice of the questions they choose and use in the class was not evident too. And so I decided to beyond my PhD focus on exemplification as a practice. I don't know whether you are familiar with that term exemplification, but simply the examples, the questions that are used in class. Those questions we solve in class when we teach. Literature calls them examples. So when I say examples, please bear that in mind. Okay, so you can't have a mathematics class where you just go and talk mathematics and you don't solve some questions. So you have to have examples that they're using in the class. And so the example is very central to the learning and teaching of mathematics. And for me, one of the things that we normally see is that whenever there is any question about how examples are used in class, a particular framework pops up, and that's variation theory. We'll talk a bit about the variation theory now. And so for me, the quest was, okay, variation theory deals more with, more with the choice of examples and less with the use of examples. So a lot of the choice of examples, but it doesn't also attend to the choice and use of examples in multilingual classrooms, and less still in preparing pre-service teachers. So then I came up with this, what I'm calling a triadic framework for understanding examples in mathematics teacher education multilingual classrooms. Okay, so I'll talk about a bit about the use of the framework. My larger research is on examples, how to use examples in multilingual classrooms, what constitutes good example, example space within pre-service teacher education, and also how to interweave language and mathematics learning opportunities. So it's not about only language, it's not about only mathematics, but weaving language into the mathematics. It's what more Prediger and co will talk about, we'll call language responsive mathematics teaching. And for me too, it's about content specific language responsive mathematics teaching. Okay. So I have mentioned that a lot of the things we see about examples, variation theory has become like the mode to pass for these studies. And so when we talk about the choice, we can very easily use variation theory to analyze the choice of examples, how the examples are chosen. But then how about how the examples are used and what other examples are generated in practice? So I'm not sure how much of variation theory is not there, but I'll get through it quickly because we can always read about it. So variation theory tries to answer a simple question. How come we have students in our class, so they are in the same space, they are taught by the same lecturer, but they come to understand the mathematics differently? How come that's possible? Or in terms of textbooks, they are using the same textbook in the same space, they are in the same context, but they come to understand the mathematics concept differently. So they attempt to answer these questions. And I have summarized variation theory here in this diagram. So, and I'll just read what is here. So at the center, for me, is the object of learning, and that is the mathematical purpose. There's always a mathematical purpose for which you are gathered in a particular class. So that's the object of learning, the object of learning, which can be intended, enacted, or lived. And then there are the critical features of that particular mathematical concept. For example, if you're talking about the equal sign, the critical aspect would be quantitative sameness. One of the critical aspects would be quantitative sameness. And basically, the example that's used usually is the example of someone who is known differently. So the way I am known in my circle of academic friends is very different from the way my wife knows me. It's very different from the way I'm known perhaps in church. It's very different from the way I'm known in the bar, for example. So the relation theory says that these different ways of knowing Tony are not necessarily wrong. They are different because they are focused on different critical features, different features of Tony, those will be the critical features. And that is why you can give your students questions, examples in the class. If they focus on a different feature, then they're not going to get exactly what you are trying to. And there's a quick example here that I've used in primary. Okay. You can give your students or your learners in the class these questions. Some of them can see this as simply a subtraction question. 17 minus 9, 27 minus 9. It's a subtraction question. And it will depend on how you teach them so that they understand that this is not simply subtraction. It's about seeing the concept of minus. When I subtract 17, there is something that's similar here. There's something that's similar too, but then this is different. And so I can say, it's just like when we go for our training, we say, okay, if I subtract 5 from 7, sorry, say if I subtract 7 from 5, no. Okay, if I say, let me put it this way. If I say 7 minus 5, I'm going to get 2. And so if I say 17 minus 5, I'm going to get something that ends with a 2. 27 minus 5. So basically, you're teaching them that there's something that is remaining constant. And so if I tell them, then it means I can go beyond the number range of that class and say, okay, what about 107 minus 5, if that's a class that ends only in 100 number range. 107 minus 3 should be able to. So it's basically about showing them the patterns too. Okay, so basically the relation theory holds that the necessary conditions for learning includes focusing on the object of learning, that's that, identifying which aspects or critical features are important, okay, and then you kind of choose questions that bring out those critical features. So like those questions will bring out, and I will use that the other example now, they will bring out the concept of minus. If I vary everything at the same time, then I'm not bringing out a particular concept I want to teach my learners. And let's use this fruit for example. So how do you know this is not rotten, yeah. So how do you know it is rotten? Okay, when you compare this, you know it is rotten because there's something you can compare it with. You can compare it with this one, and that, and then that. And normally when I teach this to the students, I'll call someone in class and say, how do you know you're a man? And then they'll give me all kinds of answers that I'm sure you can imagine. Oh, I'm a man because of, I'm not going to say some heretical stuff here. But then they'll give me some strange answers. And I said, no, you're a man because you can distinguish yourself from what you are not. You are not a woman. I can't call this a male pen. Doesn't make sense because I can't contrast it with some other thing. It's the same thing with examples in class. I have to be able to contrast this. If I only know this, then that's all I know. I won't be able to contrast it with this other one and say, okay, when the color begins to turn to brown, when it begins to become brownish, then I know it is rotten. But then the relation theory also says, if I'm varying everything at the same time, I still will not be able to make sense of the situation. If I have this bowl of fruits, and that's all I know, and I'm asked, how do I know when a fruit gets ripe? Well, this is orange in color. That's edging towards red. That is reddish. That's green. So if all I know is orange, I'm going to say, no, this is not yet. That's not yet ripe. So then, if I vary everything at the same time, it's still not helpful to students when I choose examples. So there's going to be something that is consistent. And in this particular case, what is consistent is the fruit. What is varying will be the coloration. Okay. So let's look at this example now. And this is a real example from a classroom. So this teacher gives the students, I think they're in grade 9 or 10, 9 or so, gives the students this question. And then the question for us is, what are these examples for? What is this teacher trying to teach? What is the object of learning? And when you look carefully, this can just be a simplification question. But then, if you look carefully, you see that there's something similar there. Okay, that is similar. You can see there's that here. And then you can see this. So these are not randomly selected questions. These are questions chosen because the teacher wanted to teach the learners that, or the students, that you don't cancel terms, you cancel factors. A champion of canceling term will just cancel out like this and say my answer here is 7. And so there's something also to cancel here. And so my answer becomes 3a squared. And then cancels this out, and then that becomes my answer, and so on and so forth. That would be what the champion of canceling terms. But then we can look at this and say, okay, this teacher chose these examples to be able to show that, in fact, if I were the teacher, I actually change this to 6. In fact, you cancel factors. And so the first question, there's nothing to cancel, right? Second question is something that's similar to the third, but there's also something that's different. So it's about similarity, contrast, what they call fusion, and then generality. So there's something here that is similar. There's something here that's similar to 1, 2, 3, to the 1, 2, sorry, and there's something there that's similar, but there's also something that's contrasting in these questions. And the contrasting thing will be that here a variable is introduced. Here we have an expanded version of the equation, and then of the expression, and then here the expansion has to be done on its own. So there's something that's similar, there's something that's consistent, but there's also something that is varying. Okay. And so progressively, the end result, the generality that the teacher wants the students to draw out of this is that they must cancel factors. And therefore, you see, she can do this and say, okay, if my answer is 6, let's look at this. If I say 3 plus 6 plus 6, that's 9, and I divide by 3, then I'm going to get 3 as my answer. Then we'll begin to understand that, all right, this can be rewritten as 3 into 1 plus 2 over 3, and then the factors cancel out, and the same process can be repeated there too. So the examples in themselves can be analyzed based on variation theory in terms of the choice. The use is where we need to bring in the multi-level dimension. And that's why I asked myself, what does it mean then to use variation theory in the multi-level classroom, or more specifically in teacher education classrooms? And then the words of Lester comes to mind. Yeah. So he says, rather than just simply choosing one theoretical perspective to understand your data, you could actually act as a learner by adapting ideas from a range of theoretical perspectives to suit your group. So that's what I did. So, okay, I'm in a multilingual teacher education classroom. What are the key things that are within my context? Well, first, it is important that good examples are chosen, okay, but also the language that is used to engage with the chosen examples is also very important. The language is important, so language and the multiple identities that are co-constructed through the whole interaction process is important. We're in the class where we are training pre-service teachers. We're not teaching engineers. Okay, so that the discourse we use and how we kind of enculturate them into the different identities that are interacting identities that are present, or that should be part of their training is important. Okay, so I brought in two other frameworks to complement variation theory. One is a science framework actually by Mortimer and Scott, who talks about meaning making as a dialogic process. I'm running out of time, so I'm going to go to this diagram, which summarizes meaning making as a dialogic process. Talks about, on the one end of the spectrum, you have the dialogic and authoritative discourse, and then interactive and non-interactive. And then in all these quadrants, we can have, like, this quadrant is a measure of these two. So you have a situation where it is interactive and dialogic. We need to understand that dialogue for Mortimer and Scott is not about how many people are involved in the conversation. It's more about how many ideas. It's about the ideas more than how many people. When we deal with how many people, then they talk about interaction. So if I'm teaching in the class and I'm bringing in a range of other ideas and drawing on my students' ideas and asking them to come to the board, then you will see that as a dialogic process. Even if I'm the only one talking, in science, for example, if we talk about how things came to be and we are teaching our learners about evolution, about the biblical account, about the Big Bang theory, and even if it is you as a teacher, as the teacher educator doing all that, it is dialogic for them. Okay. And then when you bring in others, then it becomes interactive, or if you don't bring in others, it's still not interactive. People struggle to understand why something can be dialogic and non-interactive. But if you understand it as dialogue, as a range of ideas rather than different people involved in the conversation, then it makes sense. Then the other theory I brought in is actually my own theory. Well, it's not a framework, let me call it framework, about the 5 interacting identities. So in any mathematics teacher education program, the pre-service teachers are becoming teachers of mathematics. They are becoming teachers of mathematics. But in my context, they are becoming teachers of mathematics in multilingual contexts. And then, but they are also becoming learners of the content, the mathematics content. And again, akin to that is the fact that they are becoming learners of the practices that are associated with mathematical practice. If, for example, I go to the board and I say, oh, how do you define, let's see, how do you define a particular concept in mathematics? Right, that is the content. How do you define X? That is the content, right? But if I teach them about what makes for a good definition, then that's a practice. Okay. And then, but again, too, they are becoming proficient language users for the purpose of meaning making and teaching and learning of mathematics. So, in merging this 3 framework, I believe first we attend to the mathematical object of learning. We attend to the interactional process that takes place in the course of the enlightenment of the object of learning, and how through this whole process we think of what facets, what dimensions of mathematics education are attended to. So I have that original summary of variation theory, and that's what you see here. That's what you see here. And on that, I have brought in the interactional process and teacher moves. But again, too, I have brought in the different interacting identities. So the way I choose my object of learning, right? I enact it, and the way I enact it, in enacting it, I use the interactional, there are certain processes, interaction that goes with the enactment. And through that, I'm either enculturating my pre-service teachers, and it's not one or the other necessarily, into either becoming learners of the content, or becoming teachers of mathematics, or becoming learners of the practice associated with mathematics, or becoming teachers of mathematics in multilingual context, and so on and so forth. I've got this in a paper that I'll share the link so that you can look to it, look at it in more detail. I'm running out of time, that's why I did introduction here. Okay, so you would notice that the arrows are bidirectional. So in a lot of the examples and in the analysis I did, you will start from the object of learning, and then you ask what critical features of that object of learning is important, and then you choose examples that actually bring out those critical features. And then when you enact those in the class, the interactional process comes in, and through that, you are either looking at this, well, as I said, it's not one or the other. You could look at any of these different facets. But as in PD programs, professional development programs, or even in teacher education classes, you can decide that, okay, I will start from outside, so from outside in. So you decide that, okay, the key thing for me for this class is I want to promote teaching mathematics in multilingual classrooms. So that's where the identity I want to incorporate my pre-service teachers to. And therefore, I'll then ask myself, okay, what examples can I choose? What are the critical features of those examples, right? And what interactional process would I need in order to be able to effectively communicate the object of learning with meaning? So it works both as inside out and outside in. Okay, and that's what I was explaining there. Okay. But beyond, and I'm going to end with that now, beyond the question of what makes for a good example or a good set of examples, there is also the whole issue of, the buzzword translanguaging, like using language as a resource and all that. So there's that buzzword. But given the context, the way I've just described it, the question then is, one of the questions when it concerns language policy, what would a full repertoire language policy look like where it is officially mandated that students can use any language available to them? Think of my context. Not here, because here you might have just 2 languages to deal with. We have a multiplicity of languages to deal with. Then, what would a full repertoire approach to teacher education? Would a full repertoire approach to teacher education be possible? What would it look like in my context, or in any context in the African continent? And then in terms of textbooks, what would a full repertoire approach to teacher education? Okay, no, I think I mistakenly copied this. So how would textbooks look like when you want to harness the importance of the multiplicity of languages that are there in the world? And by these questions, I'm in no way going back to the deficit understanding of multilingualism as cognitively not beneficial. Okay, I'm still saying that it is beneficial, but how will these things look like? So in the book that's coming out next year, January, these are some of the questions we are posing, and we are also asking, what are the different avenues for future research in language, in multilingualism in the African continent? And I must say, the reality is that Africa has championed this whole multilingual debate in mathematics education. And South Africa has been very instrumental to that. In fact, the first work that was done in language and mathematics was done by Pim, and that was in the early 80s. But then what Pim did not do is to bring in the multilingual touch to it. The person who started this whole multilingualism debate and all that is actually Jill Adler in her early work. Okay, so we have done a lot, and in this book, Richard Bowell wrote the epilogue. Richard Bowell is challenging us to continue to lead the way in terms of multilingual education globally, not just in Africa. So I'm going to stop here and ask and allow you time for questions. So that's the paper where I talk about the different ways in which the interaction within the class can enlighten one in terms of how the combined framework can be used. Thank you very much.
Turning up your screen share.
Sorry, should I do what?
No, I can do it.
Okay.
I can start with the question. Am I audible?
Yes.
Oh, good. Okay. I don't know if anyone in the room has a question. So if there's a question from the room, that should go first.
Yes, Abel.
Yeah.
I didn't put you on the spot right now.
You know, the way you present there, by the way, thank you very much for a very nice presentation. Now, my issue is that, like the way you presented, is like the teacher is the one to do the whole work. So one thing I was just wondering, what is like the contribution of learners among themselves to overcome this challenge of multilingualism?
Okay, very interesting question. Thank you very much. It's just that my work is focused on teacher education and the teacher educator, because you see, there's a lot that we as teacher educators can do and the teachers can do in class that our learners may not be able to do. A lot of the research will focus on what learners, how they navigate the language issues and all that. But if there's no direction from the teacher, then it's a problem. If I'm not able to draw on what learners are saying and use that to the advantage of the whole class, then it's a problem too. So my work is specifically focused on what teacher educators need to do. I'm quite aware that the learners also can do some things, but the learners come to class with their linguistic baggage. We need to be the ones drawing on the their linguistic prowess to be able to benefit the whole class. Yes.
So, but I thank you for the presentation. One thing I was thinking about was how do teachers most effectively address this? Because I assume not all teachers will. Like I worked with the high school. I lived in New York City for a long time. Worked with the high school where the majority of students were immigrants from mostly in like the Middle East, for example. And most of the teachers did not, like some of the teachers spoke, they all spoke English fluently and some spoke Spanish fluently as well, but most of the teachers did not speak the native languages that a lot of the students would speak. Sometimes the students would resort to speaking in a language that they were comfortable when they were working in group work to help each other out. But I think my concern was how can the teacher then be able to gather information about how the students are thinking and processing if they can't understand their language. So I guess I wonder how your work addresses that, because it seems like really an exciting thing, but I just wonder especially if all the teachers don't know like all the multiplicity of languages.
So that will fall into the category of enculturating pre-service teachers into becoming teachers of mathematics in multilingual context. And one of the ways would be simply this. Okay, so you are in the class, and by the way, the context you just described is not only in New York or here, it's also in any of the African countries where I go to a class and I don't share the same home language as many of my learners in the class. We find it often there. And so what you do in such a case, how do you draw on the learners who are actually doing the group work in a language they are comfortable with? Okay, I can give you an example. And that's one of the things we've just written about in how to promote content-specific language responsive mathematics teaching. And the question we looked at was, what mathematical register-related question would you have for your learners in the home language? Outside the example you just used, I can call a learner and say to the learner, what is, okay, we're talking about algebra and it's an introduction to algebra class in grade maybe 7 or 6 or 8. And then I'll say, okay, what would you call variable in your home language? And then they will tell you what it is, literally, and then you can then look at it from a mathematical perspective and say, okay, it is called this, but you realize that while this aspect is correct, this other aspect, it's not altogether mathematical. Okay, so you can and in that way, you are actually drawing on the learner's language to teach the mathematics. They might be others sitting in the class with the same misunderstanding. There is that research that was done by my colleague where he went into a class where they were talking about let me try to remember. Let me try to remember it. It is it's the how do you call when a graph curves that point there?
Concave.
Yeah, no, concave. Where it changes from concave up to concave. Yeah,
Inflection point.
Yes, yes. So they were looking at that, and they were asking, how do you say this in the home language? And then they were debating about that, and then eventually they realized that in fact, the English word for it is okay, the word I'm looking for is turning point. Okay, they couldn't find an equivalent word for turning point in their home language. And then on further thinking about it, they realized that in fact, when you say turning point, the reason they couldn't find a word is that it's simply because the word sounds like an oxymoron. You say the point, it is the point, but it is turning point. And that's what they couldn't. And so they had a robust discussion about how best to actually represent that term in English. And that was very different from another class where it was monolingual and they treated turning point as not problematic. So that's another way you can bring in the different home languages that you don't even understand to kind of create some mathematical meaning to what you're doing.
Well, thanks. I think I was just thinking about how, and I really appreciate that, just how trying, because like when I'm teaching, I would want to do my best to understand what my students are thinking, which is even in the same language as me is hard, is I feel like already tricky, you know what I mean? So it's just trying to think how to do a good job of that in that situation so students can still use their own language and be empowered to do that. That was really cool to experimentation like going.
Thank you. I also think we also are under the impression that it is a straightforward matter that someone can actually go to such a class and teach. Yeah, without training. And the finger points again at us, educators. Yes, we need to train teachers who are, in my context, there is they start off in the home language and transition to English in grade 4. We need to train teachers to manage that transition. We need to train teachers who are going to be teaching in such a class on how to teach, how best to teach in a class when you have people who don't understand, who are not fluent in the majority language. It's not straightforward that someone who's been doing the mathematics in English in a particular environment will just be thrown to that environment and the person will immediately know what to do. And we can't rely on only craft knowledge. So again, as I said, the finger points at us, teacher educators, what are you doing to train teachers who are able to deal with such situations?
May I ask a question? Can you hear me from the crowd?
Yes, dear.
Oh, wonderful. Okay. I'm just, Tony, this is really thought-provoking and getting me thinking about, I think what you're leaning towards and what Blue's question led us to is thinking about how teachers manage this heterogeneity in their classroom as a resource rather than as a burden or an extra extra work I have to do. And one thing that, just to editorialize for 10 seconds, I think it's really valuable to be in a setting where it is always hard to make sense of students' thinking and their mathematical thinking, and it happens mediated through language. So being in a multilingual setting actually makes that clear. Like, it's also true in a supposedly monolingual setting, but it's now abundantly clear, right? And Judith Moskovich has written about this, that in a multilingual setting, language is part of the mediation of this interaction. And I guess the question I have for you is that language is also connected very strongly to identity, right? In multiple ways. And I wonder if you have, I may be adding one more layer, but you had that in your diagram. So I'm wondering how you think about the work of developing teachers' identities in this multilingual context, and some of the, I guess, the challenges and opportunities that you see related to that.
So by identity now, you mean identity in terms of the languages they speak, right?
Potentially, right. Or also, and there's many layers, right? There's my identity as a doer of mathematics. There's also my identity as a doer of mathematics in English. My identity of my school's forcing me to teach in English, but I don't like to do that. I can imagine lots of different nuances kind of coming out of that interaction. I'm curious how that factors into your work.
Okay. So, I have looked at identity in a particular way, and I was drawing on Wenger's notion of identity as a constant becoming. And that's why you keep saying becoming this, becoming that, becoming that. So that's the particular notion of identity that I used in my work. And I drew obviously on literature, in mathematics education to be able to tease out these different identities. But you're adding another layer, as you said, and it is a layer I have not looked at because I wanted one thing to be clear, that we need to be looking not only on language. A lot of research on language in mathematics classrooms have been criticized to be so biased towards language at the expense of the content. So that's one of the things I was kind of guiding against, that the content in all this is not lost. If I had focused more on that type of identity that you've talked about, I would have been, yes, you did mention doers of mathematics. I would have been more biased towards the language aspect than towards the mathematics. So the mathematics must not always be lost. And of course, it is a particular kind of study that you can one can embark on, and it was not really the focus of what I wanted myself.
Yeah. Okay, that's great. Thank you. And I appreciate that idea of keeping the mathematics central.
Yes.
And noting the time, I know it's about time for one more question if folks want to add one more. Hard to moderate from outside the room.
Yeah.
So in this, even as a practitioner, right, as a teacher, you understand the language, right? There's still kind of a lot of responsibility to kind of prepare students with the language that is used, let's say, in the future, right? So for example, I taught in a school where it was a ton of Spanish speakers, which I'm fine with, and I understood that my students understood the topics, but then their expression of those concepts in English were not as strong. So then they're moving on to advanced class, and I say, yes, I understand you understand the topic, but you're moving on, and then like the vocabulary is a big part not of their understanding or their learning, but as a requirement, right? So kind of there's an important balance with 1 or 2 language or 4 languages, right?
Yes, absolutely. The mathematics register is always important. The mathematics register poses problems not only to those who are multilingual, but also to even the monolingual learners. But then if you are multilingual, it adds an extra layer of complexity where you are learning mathematics in a language that's not your home language. And then there's something I didn't talk about, and that's like structural differences between the language. You saw me struggling earlier on with what did I say? I did say subtract 3 from 5 from 7, and you see, subtract 7 from 5 and all that. So that's because, the different languages have different structures. In French, you would say, and because I did some studies in French, I've actually lost it now. When you say the first five learners, French will swap it around, say the 5 first learners, something like that. Now I don't even know which is correct again in English. Yeah, you see, so that structural difference plays a lot into the mathematics and plays a lot into the mathematics and enables either one to understand the mathematics in a particular way or in another way. And that's an extra layer that, see, if English is my first language, it's my language, I'm familiar already with the structures, the linguistic structure of English, and therefore bringing in the mathematical structure, because mathematics is also a language, will be easier for me than someone who has learned English and then has to deal with now not just learning English, but learning the structure of English and learning the mathematical structure, the structure of mathematics in English. Okay.
I think we are officially at 1 p.m. and I want to, as a good host, make sure that folks feel ready to end promptly. But I want to pause and just thank you, Tony, very much for your wonderful presentation, and maybe take a moment to welcome and thank you.